The question number 21 is, a boy has 50 kg mass. He wants to float in river with the help of a wooden log. If the relative density of the wood is 0.8, then the minimum volume of the wooden log would be. These are four options. Now dear student, let's say this is the volume of the log. Then one will be the 50 kg man and second would be this log weight, and that would be equal to the buoyant force, just to balance, and volume is fully submerged. So in this case, the buoyant force is equal to the volume of the block, let's say V, into density of the water, which is 1000, into G, and that is balanced by the weight, which is equal to 50G. The mass of the block is volume into density into G. So you have to solve this equation. Therefore 1000 into V is equal to 50 plus 800V. So 200 V is equal to 50 and V is equal to 1 by 4 meter cube. So the correct option is the option second. Answer is 2. The question number 22 is, a solid sphere of radius capital R made up of material having bulk modulus B is surrounded by a liquid in a cylindrical container. A massless piston of area A floats on the surface of liquid. When mass M is placed on the piston and compress the liquid, the fractional change in radius of the sphere. Now, this question is on bulk stress. And this is a piston with area of A, and you put the load on this one, mg. Because of this one, there will be pressure, and due to excess pressure, the volume will change. And we know that if P is the excess pressure, so this would be the beta into delta V by VA without I have taken sign. So and pressure is equal to how much? That is equal to mg upon area. Area is A and beta into delta V by V. Say mg upon BA is equal to delta V by V. Now to find the radius, the volume is equal to 4 by 3 pi r cube, and by the error analysis, delta V by V will be equal to 3 delta R by R. So I can replace this by 3 delta R by R, and the frictional change in radius delta R by R is equal to mg upon 3 VA. Look the option, mg upon 3 VA is the option number 2. So answer to this question is 2. The question number 23rd says that if the reflectance and the transmittance of a bodies are 0.4 and 0.3, then its absorptance would be. So dear student, whatever you throw on this body, and what happens, part of this is reflected, part of this is absorbed, and part of this could be transmitted. Then absorptance coefficient plus transmitted plus reflectance is always equal to 1. And reflectance is given 0.4, transmittance is given 0.3, then absorptance you can calculate, so absorptance is equal to 0.3. Therefore the answer to this question is first option. Question number 24 is, three rods of same length and area of cross section but of different thermal conductivities. They are connected in series in the same order. The free end of the first rod is at 0 degrees centigrade and the free end of the third rod is at 55 degrees centigrade. In steady state, the temperature difference across the middle rod. Now if I draw the diagram, the first rod, this is 0 degrees centigrade and joined to another identical rod 2, and then the third rod. This temperature is 55 degrees centigrade and this was 0 degrees centigrade. The conductivity of this is K, 2K and 3K. What is required? The temperature difference across these points. And let's say their temperature difference is delta T. Now what happened? The heat will flow from higher temperature toward the lower end. And what would their thermal resistance? The resistance is equal to L upon Ka. Now area are same, length are same, then R is inversely to K. So if I draw the resistance diagram, if I take this resistance as R, then this resistance will be R by 2 and this resistance would be R by 3, thermal resistance. Now, you know what is the heat flowing? The flowing per unit time is temperature difference divided by the resistance. And if applied to the whole rod, then I write 55 minus 0 divided by R plus R by 2 plus R by 3, and that should be equal to the resistance, temperature difference here divided by resistance of this, which is equal to R by 2. And delta T, you want to find out the temperature difference. So 55 divided by 1 plus 1 by 2 plus 1 by 3 is equal to delta T divided by 1 by 2. So cross multiply and solve, the delta T comes to be 15 degrees Celsius. So temperature drop across this section is 15 degrees Celsius. So answer is 1 to this question. Question number 25 says a thin spherical conducting shell of radius 2r has charge q. Another charge 2q is placed at the center of the shell. The electrostatic potential at point at distance r by 2 from the center of the shell. Let's given this a big shell with the radius of 2r, and it's given the charge of q, and it says at the center of this another charge of 2q is placed here, and you have to find the potential at point P, which is at distance x is equal to r by 2. So now by the rule of superposition, total potential will be equal to because of this and because of this charge. Now what is potential due to this? That is equal to kq by r, which is 2r. The potential of the surface will be anywhere inside, and potential due to this charge at this point is equal to k into 2q divided by the distance is r by 2. So that is equal to kq by 2r plus 4 kq by r. So this is 2r divided by kq plus 8 kq, and the potential is 9 kq divided by 2r, and k is 1 by 4 pi epsilon naught. So this is 9q divided by 8 pi epsilon naught r. So answer to this question is the third option.